Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is a tertiary alkyl bromide. The central carbon bears Br, CH to CH3, ethyl, CH2 et, another ethyl, since et is equal to CH to CH3, and CH2, NPR, N-propylmethylene is equal to CH to CH to CH to CH3. Wait, let me reread. The structure is CH3, CH2, Br, CH2 et, CH2, NPR. So the central carbon has 1 Br, 1 ethyl, CH to CH3. From the left chain, CH3, CH2, 1 CH2 et group, and 1 CH2, NPR, group. This is a tertiary bromide. Moving on to the next step. Alcoholic KOH promotes E2 elimination by molecular elimination. The base abstracts a beta hydrogen while Br leaves. Moving on to the next step. The beta carbons are the CH2 groups attached to the central carbon A, CH2 of the ethyl group from CH3, CH2 side, B, CH2 of the CH2 et group, and C, CH2 of the CH2, NPR, group. All three CH2 groups adjacent to the quaternary-like carbon bearing Br are beta carbons. And for the final step, the major product of E2 elimination is the more substituted, more stable alkene. Elimination toward the CH2 et group gives the double bond forms between the central carbon and the CH2 of CH2 et, giving a trisubstituted alkene where the double bond carbon has Me from CH3CH2 after losing one H from CH2. Wait, actually the central carbon becomes the alkene carbon. Let me reconsider the structure. The central carbon C has CH to CH3. Call it branch A. CH2 et is equal to CH to CH to CH3. Branch B, which is actually N-propyl when et is equal to C to H5. So CH to CH to CH3. CH2, NPR, is equal to CH to CH to CH to CH3. Branch C, N-butyl chain, and Br. So branches, ethyl, N-propyl, from CH2 et where et is equal to C to H5, and N-butyl, from CH2 NPR where NPR is equal to C3H7. E2 gives alkene. The double bond forms between the central C and one of the adjacent CH2 carbons. The more substituted alkene is preferred. Elimination towards CH2 et, giving is equal to CH, CH3 on that side, with et and NBU on the other carbon, gives a trisubstituted alkene. The central carbon of the alkene retains two substituents. The major product corresponds to elimination giving the most substituted double bond. With substituents Me, et on one carbon and Pr on the other carbon of the double bond, as in option C, where the double bond carbon bears Me and et, making it a 1,1 disubstituted type with the other carbon bearing CH to Pr. This is the most substituted alkene, trisubstituted overall considering all groups. Option C shows the double bond with Me and et both on one carbon is equal to C, Me, et, end, and CH to Pr on the other carbon, representing elimination of H from the CH2 of the ethyl group giving a more substituted alkene with the double bond carbon bearing two alkyl groups, Me and the remaining part. This corresponds to the Zaitsev product. Options A and B show less substituted or differently connected alkenes. Option D has a different connectivity. Option C is the most substituted alkene product consistent with Zaitsev's rule for this tertiary bromide under E2 conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.